Hi there, I'm Sridhar Chandrasekharan, and I'm presenting a study series on power transmission line construction. Drawing from my extensive career experience, this series is designed to provide practical and theoretical insights that can be directly applied to real-world projects. We began this journey by exploring the basics of electricity, how it's generated, its requirements, and its sources. From there, we've covered critical stages such as tendering, bidding, and project initiation. Moving forward, we'll delve into implementation, execution, and finally, project handover. Given the complexity of this topic, the content is divided into chapters released fortnightly. Along the way, we'll also integrate discussions on essential complementary areas, including engineering ethics, legal considerations, health and safety compliance, human resource management. These vital aspects will be seamlessly woven into our technical discussions to provide a holistic perspective. Each fortnight, I'll release a new video featuring key technical topics, ethical dilemmas, and considerations, a thought-provoking quote to inspire meaningful reflection. Currently, we're in Chapter 13, completion part of survey activity. There's still so much more to discover, so stay tuned for the upcoming chapters. Thank you for joining me on this journey of learning and growth. Disclaimer. Just a quick note. The content in these videos is meant for informational and basic educational purposes only. These videos aren't intended to provide professional advice or endorsements. This helps set the right expectations about the nature of what we're sharing, especially since we draw on material from various sources under the principle of fair use. In the last two chapters, we focused on understanding the survey process, covering topics such as route surveys, detailed surveys, and profile plotting. In this chapter, we will address the remaining topics. In the current chapter, we will begin by exploring the check survey and the importance of the cross-diagonal profile, followed by an introduction to the Geographic Coordinate System, which will conclude our discussion on survey activities. As we delve deeper into the full range of construction activities and their corresponding procedures, we will follow a logical and systematic sequence from start to finish. Each task will transition seamlessly into the next, ensuring smooth and efficient progress throughout the construction phase. The key topics to be covered during the construction phase, as previously outlined, include a variety of subtopics. Let us now outline the main areas of focus for transmission line construction. Site handover, covered in Chapter 11. Survey was introduced in Chapter 11, where we covered some topics, and we continued to expand in Chapter 12. In this chapter, we will complete all discussions related to survey activities. The following topics will be explored in greater detail in the upcoming chapters. Coordinate system, geode, ellipsoid, bush clearing, tree cutting and access road, soil investigation, foundation, tower erection, stringing, checking, and energizing. Stay tuned as we explore these topics in greater depth. Let us understand about check survey. As we have completed key topics such as route survey, detailed survey, and profile survey, we will now move on to the fourth topic in surveying, the check survey. Let's begin by understanding its purpose and significance in transmission line construction. Once the transmission line's tower spotting and terrain profile have been approved by the consultant engineer, CE, and the client, a check survey is conducted as a final validation step before construction begins. This survey ensures that the approved profile and tower placement coordinates align with actual field conditions. Any discrepancies found are addressed to prevent issues during execution. The objectives of the check survey is to ensure that the approved transmission line profile accurately reflects real-world conditions. Verify the correct positioning of towers, spans, and clearances as per the terrain. Identify any modifications in land use, vegetation, or environmental factors that may have changed since the initial survey. Assess possible new obstacles like new constructions, water bodies, or restricted areas. Review any sections that required further clarification or had pending approvals. Verify the feasibility of tower locations in challenging terrains, hills, river crossings, or unstable soils. Modify tower heights, spacing, or alignment if required due to unforeseen ground conditions. Optimize sag and clearance in case of deviations in terrain elevation. Ensure adherence to national and international standards for ground clearance, conductor sag, and tower positioning. Confirm that all clearance requirements over roads, railways, rivers, and settlements are met. The importance of the check survey is to eliminate misalignment issues before the foundation work begins. Confirms that tower placements are practical and achievable in the field. Addresses potential challenges in unstable or sensitive terrain. Adheres to safety, environmental, and regulatory guidelines. Reduces the need for rework and project delays. The check survey acts as the final verification before actual construction begins, ensuring the successful and error-free implementation of the transmission line. Now let us understand how check survey is implemented at site. The check survey is a crucial final step conducted after the tower spotting and terrain profile approval to validate alignment, tower locations, and field conditions before construction begins. It ensures that the approved profile coordinates align with real-world conditions and helps in identifying any necessary modifications. To initiate preparation and review of approved profile, gather all relevant documents, including approved alignment plans, tower spotting coordinates, elevation and terrain data, clearance details for roads, railways, and rivers. Secondly, equip the survey team with tools such as GPS devices, total stations, theodolites, and drones, maps, satellite imagery, and GIS software. Once all set, physical field verification can be initiated. Surveyors and the team visit the entire transmission line route to confirm the actual tower locations with reference to approved coordinates. Check if the alignment path is free from new obstructions like buildings, vegetation, or land use changes. Identify terrain-related challenges such as steep slopes, flood-prone areas, or unstable soil. Firstly, tower spotting validation is done to verify the markings for each tower location in the field. Ensure proper spacing and orientation of towers as per the approved design. Adjust tower placements if required due to topographical changes or accessibility constraints. Secondly, clearance and obstacle assessment has to be observed, like inspect road, railway, river, and settlement crossings for any design adjustments. Verify that planned access roads and logistics arrangements are feasible for construction. Confirm compliance with right-of-way guidelines and land acquisition approvals. Documentation and reporting has to be done to notify the CE and client. Record any deviations from the approved profile. Recommend necessary modifications for tower heights, foundation types, or span lengths. Submit the final check survey report to the consultant engineer CE and client for approval before construction begins. Site inspection by CE on check survey. Once the check survey is completed, the consultant engineer CE conducts a thorough site inspection. This inspection ensures that the findings of the check survey align with the approved profile, technical standards, and field conditions. It is a crucial step before commencing construction to validate the contractor's work and address any discrepancies. CE will verify the accuracy of tower locations, alignment, and inspect the physical alignment to confirm markers and coordinates match the updated profile. Assess the alignment path for any new obstacles, e.g. vegetation, structures. Verify the proposed locations of towers, especially in critical areas such as angle towers, tension towers, crossing points, roads, rivers, railways. Ensure adequate space is available for foundations and construction access. Verify the suitability of tower locations in hilly areas, flood zones, or areas prone to soil erosion or landslides. Evaluate soil stability at tower locations to ensure proper foundation design. Ensure minimal impact on vegetation, wildlife, and protected zones. Focus on specific sections where the alignment might have deviations or challenging terrain. Verify modifications recommended during the check survey, such as tower relocation, adjustments to span lengths, additional engineering measures for stability. Confirm that the contractor's adjustments during the check survey are valid and justified. They will ensure the alignment complies with safety, regulatory, and environmental requirements. Highlight any remaining challenges, for example, inaccessible areas, unstable soil, or new obstacles, and recommend solutions. Once they satisfied with the checking, CE will provide the final go-ahead for construction based on field readiness and design alignment. CE approval on check survey after site visit. After the consultant engineer, CE, completes the site visit to verify the contractor's check survey, their approval signifies that all field data, alignment details, and project conditions are satisfactory and aligned with the design specifications. This approval is a critical milestone as it clears the way for construction activities to begin. The CE's evaluation ensures accuracy, compliance, and readiness for the next phase of the project. The CE issues a written approval to the contractor and client, confirming that the check survey has been verified and accepted. The document includes approved alignment plans, finalized tower spotting data, clearance compliance verification, any additional recommendations for smooth construction. Once approval is granted, construction activities such as excavation, foundation laying, and tower erection can commence. CE approval after the site visit is a crucial step that validates the check survey and ensures the project can move forward confidently, maintaining technical integrity and operational safety. Now let us understand cross-diagonal profile. What is cross-diagonal profile? A cross-diagonal profile is a specific surveying and profiling method used in transmission line projects or other linear infrastructure projects to assess the terrain diagonally across the route. It provides a detailed understanding of the ground conditions along diagonal sections that are crucial for designing towers, optimizing placements, and ensuring mechanical stability. Assessing uneven terrain. It helps evaluate terrain variations that might not be fully captured in standard longitudinal or straight-line profiles. Used to spot low points, high points, slopes, or uneven land that may impact tower spotting or conductor sag clearance. Provides additional data to determine if an alternate tower type or height is required. Ensures that weight spans and mechanical loads on the towers are evenly distributed across diagonal sections of the route. How cross-diagonal profiles are recorded. Survey engineers collect terrain data by measuring detailed elevation points across the corridor and along the route to capture height variations and slope gradients. This is particularly important in areas with crossings, undulations, or steep slopes. Using software like PLS-CAD, the diagonal data is plotted alongside the main profile to ensure ground clearance is properly maintained. Conductor sag and tension calculations are accurate. Undulated tower placement is optimized. Foundation protection measures, such as retaining walls, are identified where needed. The cross-diagonal profile is then overlaid on the main profile to identify areas that may require taller or shorter towers for optimal alignment. Changes in tower spacing or type based on terrain conditions. Additional supports or foundation adjustments to enhance stability. This process ensures structural integrity, enhances safety, and optimizes tower placement across diverse landscapes. Where cross-diagonal profiles are critical. Cross-diagonal profiles are critical in steep or uneven regions. They help adjust tower placements and conductor sag to meet safety and design standards. These profiles also ensure adequate clearance and help identify whether diagonal loads affect crossings. Additionally, they assist in planning tower placements to minimize environmental impacts. By complementing the main profile, a cross-diagonal profile provides a 3D perspective of the terrain. It ensures conductors have sufficient clearance from the ground and nearby structures and reduces the risk of rework by identifying potential issues early in the design phase. This makes the cross-diagonal profile an essential part of detailed transmission line design, ensuring mechanical stability, safety, and efficiency by offering accurate terrain and tower placement assessments in challenging sections. examples, and applications. To explain further, let's explore real-world site conditions and the importance of cross-diagonal profiles, particularly in sloped terrain scenarios for tower placement and conductor sagging. First, tower placement in sloped terrain. When placing a tower on sloped terrain, two main challenges arise. Tower stability. The sloped area beneath the tower must be leveled, which often requires land cutting and leveling. This process lowers the terrain level and may lead to additional challenges. Alternatively, the slope can be stabilized by cutting and benching, with retaining walls introduced to secure the foundation. Cost management and safety. To minimize costs while maintaining safety, different tower leg extensions can be introduced based on the terrain condition. For very steep slopes, a combination of leg extensions, leveling, and benching with retaining walls may be necessary to stabilize the tower footing and optimize costs. For this, the cross-diagonal survey is essential here to assess the slope's condition and determine the most efficient and stable tower placement solution. Secondly, for conductor sag and ground clearance, in spans between towers, the conductor sag level must be adjusted based on the ground profile and elevation. For higher voltage levels and tower configurations where conductors are widely spaced from the center, the ground clearance may reduce significantly in regions with steep terrain slopes. This is especially true when the transmission line runs parallel to hilly terrain, where the natural slope increases the risk of reduced clearance. The cross-diagonal profile helps identify such situations and adjust sag levels to ensure compliance with ground clearance requirements. Third, tension towers in slope areas. When placing tension towers on slopes, special attention is required for conductor jumpers, which form loops projecting toward the ground. On elevated terrain, these loops can further reduce ground clearance, creating potential safety hazards. Even with leg extensions or leveling and benching, it is critical to ensure adequate clearance on the conductor jumper side. A cross-diagonal survey is necessary to account for these scenarios and provide accurate terrain slope data to optimize tower placement and jumper configurations. The cross-diagonal profile is indispensable for transmission line design, especially in hilly or uneven terrains. It provides critical data for 1. Slope stability for tower foundations, 2. Adjusting conductor sag and maintaining ground clearance, 3. Designing towers and jumpers in challenging slope conditions. By integrating cross-diagonal profiles into the design process, engineers can enhance stability, safety, and cost-effectiveness while ensuring compliance with design and safety standards. With this, we have completed major activities related to survey engineering. Now let us understand what are the tools and equipments used in survey work. Now, let us know what are the tools and tackles used in survey activity. Survey activities in transmission line projects involve precise measurements, terrain mapping, and data collection to ensure accurate alignment, tower placement, and compliance with design specifications. Various specialized tools and equipment, referred to as tools and tackles, are used to conduct these surveys effectively. Below is an overview of the most commonly used tools and tackles in transmission line survey activities. Total station. The purpose of using a total station is a key surveying instrument for measuring horizontal and vertical angles, distances, and coordinates with high precision. The functions are for distance measurement using electronic distance measurement, EDM, angle measurement for accurate tower alignment, collecting survey data to be fed into design software like PLS-CAD. Total stations are used for route surveys, detailed surveys, and tower location marking, global positioning system, GPS devices. The purpose of using GPS devices are to determine the exact geographical coordinates of points along the transmission line route. The functions are it provides precise latitude, longitude, and elevation data for route alignment, helps in verifying the location of towers and landmarks, essential for route surveys and ensuring alignment with design specifications. GPS are used for establishing route coordinates, marking tower locations, and verifying the survey alignment. Theodolite. The purpose of using a theodolite is a precision instrument for measuring horizontal and vertical angles. It is particularly useful in rugged terrains where angle measurements are crucial. The functions are: it measures angles for tower spotting and route alignment, ensures accurate placement of towers based on angle and distance, used for route surveys, cross-profile surveys, and angle checks in hilly or challenging terrain. Auto level and staff. The purpose of the auto level is a leveling instrument used to measure height differences across the terrain. It is used along with a leveling staff to determine elevation changes. And the functions are: it helps to determine the level at regular intervals for accurate profiling, measures the height difference between points to ensure uniform ground levels. It's used for detailed surveys, especially in hilly terrain where elevation differences must be accounted for in tower placement. Measuring tape. The purpose of measuring tapes are basic yet essential tools for determining distances on site. The functions are: it used for short distance measurements, such as during site preparation and tower location marking, ensures that the distances between points are accurate during on-site activities, and it's used for measuring clearances, foundation dimensions, and other small-scale measurements. Range poles. The purpose of range poles are long, marked poles used to establish straight lines and sighting points during surveys. And the functions are: it's used as markers to establish reference points for the survey team, helps maintain alignment during route surveys and tower spotting. It's used for marking alignment lines and reference points during survey work. Prism reflectors. The purpose of prism reflectors work in conjunction with total stations to measure distances accurately by reflecting the laser emitted by the total station back to the device. The functions are: it provides precise distance measurement over long stretches of terrain, used to measure between fixed points during surveys, and it's used for distance measurement during route and detailed surveys. Clinometers, slope meters. The purpose of clinometers are used to measure the slope or inclination of terrain, and the functions are: it measures angles of elevation or slope, especially in hilly or uneven terrain, ensures that slope data is accounted for in tower placement and design, and it's used for measuring slopes and elevation differences during route and detailed surveys. Pegs and markers. The purpose of pegs and markers are used to demarcate specific points during the survey, such as tower locations or route alignment points. The functions are: mark positions for tower spotting or access roads, helps in visualizing the route and ensuring the correct placement of transmission line components. It's used for marking tower locations, access roads, and other important points during the survey. Drone or unmanned aerial vehicles, UAVs. The purpose of drones are increasingly being used in surveys to capture aerial images and perform topographic surveys in difficult-to-access or expansive areas. The functions are: it provides aerial views and real-time images of the terrain, collects topographical data for areas that may be difficult to survey manually. It's used for conducting route surveys in challenging or remote terrains, capturing aerial imagery and mapping large-scale areas. Survey flags. The purpose of survey flags are colored markers used to indicate specific survey points, such as alignment, tower locations, or areas of interest. The functions of visual markers that help surveyors and construction teams identify critical points can be used to mark boundaries, routes, and positions during the survey, and its pool used for marking survey points and route alignment during the survey. Computer or tablet with PLS CAD software. The purpose of computers or tablets with PLS CAD software are used to process survey data and generate transmission line profiles and designs. And the functions: it stores and analyzes survey data, generates tower profiles, alignment sheets, and conductor sag calculations, helps ensure that survey data is aligned with the transmission line design criteria. It's used for analyzing data from the survey and generating design outputs for approval by the consultant engineer. Laser rangefinder. The purpose of a laser rangefinder is used to measure distances using laser technology, especially when terrain is difficult to access. The functions: it measures long distances accurately without physical access to the endpoint, ideal for measuring across rivers, valleys, or other obstacles. It's used for measuring long distances during surveys, particularly where physical measuring tools cannot be used. Digital elevation models, DEM. The purpose of digital elevation models, DEMs, are used to represent the terrain's surface and are often utilized in conjunction with PLS CAD for profile creation. The functions: it provides accurate terrain elevation data for the route, helps in identifying challenging areas like hills or valleys that need specific tower designs, and it's used for creating detailed terrain profiles for transmission line routing. Handheld two-way radios. The purpose of communication tools: it is used by the survey team to coordinate activities in the field, especially in large or remote areas. The functions are: it enables efficient communication between team members working in different locations, ensures accurate and coordinated measurements. It's used for field communication during survey operations. Data loggers or recorders. The purpose of data loggers are used to record environmental conditions or specific measurements during the survey. The functions: it logs data such as temperature, wind speed, or elevation at specific points, provides accurate records for later analysis and design adjustments. It is used for recording environmental data and specific measurements during detailed surveys. Vehicles used in survey activities. Survey activities for transmission line projects require a combination of specialized vehicles and tools to facilitate accurate data collection, efficient movement across challenging terrain, and proper transportation of equipment. The vehicles help in transporting surveyors and equipment to and from the site, while the tools ensure precise measurements, terrain mapping, and profile creation. Below is an overview of the commonly used vehicles and tools for survey activities. Four-by-four off-road vehicles, SUVs or trucks. The purpose: it's used for transporting the survey team and equipment across rough and uneven terrain, especially in remote or hilly areas. The features are: high ground clearance and off-road capability, capable of navigating through challenging terrains such as muddy, rocky, or uneven surfaces. Use for essential for accessing remote locations along the transmission line route that may not have well-established roads. Motorbikes, ATVs, all-terrain vehicles. The purpose: it's used to access areas where larger vehicles may not be able to go, especially in dense forests, steep hills, or narrow pathways. The features: lightweight and agile, allowing surveyors to navigate tight spaces and difficult terrains. The usage: it's ideal for rapid movement across short distances or through difficult areas during detailed surveys. Drones, unmanned aerial vehicles, UAVs. The purpose: although not a traditional vehicle, drones serve as aerial survey vehicles, providing real-time data collection and aerial imaging in inaccessible areas. Features are: it's equipped with high-resolution cameras and GPS systems. The usage: it's used for aerial surveys to capture data over large areas, rugged terrains, or locations difficult to reach by ground. Boats. The purpose: it's used in water crossing areas, rivers, lakes, where part of the transmission line survey involves water bodies. The features are: its stable platforms for carrying survey equipment and team members. And the usage are: it's employed in areas where the transmission line crosses water bodies to perform survey activities from water-based platforms. Understanding geoid, ellipsoid, and datum in surveying. When conducting surveys for transmission line projects, it is essential for engineers and supervision teams to have a basic understanding of how coordinates are derived and plotted on the Earth's surface. These concepts are fundamental for ensuring accuracy in measurements, tower placements, and alignment of the transmission line. In this section, we will explore three important terms that relate to survey coordinates and plotting: geoid, ellipsoid, and datum. We will cover this in detail in our next chapter, where we will dive deeper into the concepts of geoid, ellipsoid, and datum, and explore how they are applied in the survey process for transmission line projects. This will provide a clearer understanding for the engineering and supervision teams on the importance of accurate coordinates and plotting in successful project execution. In this chapter, we covered the essentials of route survey, detailed survey, profile plotting, and check survey, along with how profiling is executed using PLS CAD software. Additionally, we discussed the equipment and vehicles commonly used in survey activities. This provides a foundational understanding of survey work for project engineers. In the next chapter, we will explore the Geographic Coordinate System in more detail. In our study program, we have consistently emphasized the principles of professional ethics, covering all related topics in previous chapters. We have also introduced the subject of legal compliance and plan to explore additional areas, including human resources, HR, and health, safety, and environment, HSE, in future chapters. Today, as a continuation, we will delve into legal compliance in corporate business for professionals and staff. This new topic aims to provide valuable insights, and we hope it will be beneficial for all our viewers. Legal compliance refers to the adherence to laws, regulations, standards, and ethical practices that govern corporate activities. For corporate professionals, understanding and following these requirements is essential for maintaining the integrity, reputation, and success of both the individual and the organization. Legal compliance is a critical component in corporate governance and business operations, helping professionals navigate complex regulatory environments, avoid legal issues, and ensure ethical business practices. Let us understand the aspects of legal compliance for corporate professionals. These are following topics we will be covering in our chapters. 1. Relevant laws and regulations. 2. Corporate governance and ethical standards. 3. Compliance with employment laws. 4. Data privacy and protection. 5. Anti-corruption and anti-bribery laws. 6. Environmental compliance. 7. Financial and tax compliance. Till this topic 7 we have covered in our earlier chapters. And today we will cover intellectual property, IP compliance. Later in our upcoming chapter, we will cover implementing legal compliance in the workplace. Legal compliance for corporate professionals. Intellectual property, IP compliance, is a critical aspect of corporate legal compliance, ensuring that organizations respect, protect, and legally use intellectual assets, both internally and externally. Corporate professionals must adhere to intellectual property laws to prevent unauthorized use, infringement, or mismanagement of IP, which includes patents, copyrights, trademarks, and trade secrets. First, understanding intellectual property, IP rights. IP rights refer to the legal protections given to creators and owners of original works, inventions, brands, and trade secrets. The primary types of IP include: it protects the patents, like new inventions or processes. It protects the copyrights, original creative works like books, software, music, and videos. It protects the trademarks, brand names, logos, and symbols that distinguish products or services. It protects the trade secrets, confidential business information that provides a competitive advantage. Corporate professionals must ensure that their organizations comply with IP laws to avoid legal disputes and reputational damage. Second, ensuring compliance with IP laws. Organizations need to establish robust policies and procedures to safeguard their own IP while ensuring that they do not infringe on the IP rights of others. The key compliance measures include: 1. IP registration and protection. Companies should register patents, trademarks, and copyrights to secure legal ownership, maintain up-to-date records of all registered IP, and renew them as required. 2. Respect for third-party IP. Ensure that employees do not use copyrighted materials, patented technologies, or trademarks without authorization. Secure licensing agreements before using third-party intellectual property. Conduct IP audits to assess compliance and identify potential risks. 3. Internal IP management. Educate employees on IP policies, including proper handling of confidential data and trade secrets. Implement non-disclosure agreements, NDAs, for employees, contractors, and business partners handling sensitive information. Clearly define IP ownership in employment contracts, particularly in research and development, R&D roles. 4. Software and technology compliance. Ensure that all software used within the organization is legally licensed and compliant with vendor agreements. Prohibit the use of pirated or unauthorized software within the corporate environment. Conduct regular software compliance audits to prevent potential legal risks. 3. Consequences of non-compliance. Failure to comply with IP laws can result in severe legal and financial consequences, such as 1. Legal penalties and fines. Companies may face lawsuits, penalties, and compensation claims for IP infringement. 2. Reputation damage. Unauthorized use of IP can harm an organization's reputation, leading to loss of trust from customers and partners. Business risks. Using unlicensed software or technology may lead to security vulnerabilities and operational disruptions. 4. Loss of competitive advantage. Lack of IP protection may result in competitors using stolen trade secrets or innovative ideas. 4th, best practices for corporate IP compliance. To ensure adherence to IP laws, organizations should adopt the following best practices. 1. Develop a corporate IP policy. Establish clear guidelines on how IP is created, used, and protected. 2. Regular IP training for employees. Educate employees on IP rights, licensing agreements, and compliance obligations. 3. Conduct routine IP audits. Regularly review company IP assets and usage to detect potential risks. 4. Implement digital rights management, DRM. Use security tools to monitor and control access to proprietary digital assets. 5. Monitor market for infringement. Track and protect against unauthorized use of company trademarks, patents, and copyrighted materials. Intellectual property, IP compliance, is a crucial aspect of corporate legal responsibility. By respecting IP laws, protecting their own intellectual assets, and avoiding infringement of third-party rights, corporate professionals help safeguard innovation, maintain corporate integrity, and prevent legal liabilities. Adopting strong IP policies and regular compliance audits ensures that organizations operate within the legal framework and maintain a competitive edge in the market. Today's quote is from H. Jackson Brown, Jr. "The best preparation for tomorrow is doing your best today." This quote emphasizes the importance of present efforts in shaping future success. It highlights the idea that our actions today, how well we work, how much effort we put in, and how committed we are, will determine the results we achieve in the future. Here's a deeper analysis of its meaning. Instead of worrying about the future or dwelling on the past, this quote encourages us to channel our energy into what we can control today. By being proactive, staying disciplined, and putting in consistent effort now, we lay a strong foundation for a better future. By doing our best each day, we develop skills, gain knowledge, and build experiences that prepare us for greater challenges ahead. Whether in education, career, or personal development, consistent effort leads to steady progress and improvement. Many people postpone taking action, thinking they will have time in the future. However, failing to give our best effort today can result in missed opportunities and regret. Success is built through small, consistent actions over time, rather than sudden leaps. In many aspects of life, whether in business, academics, or personal growth, thorough preparation today leads to better outcomes tomorrow. Just as a student who studies daily is better prepared for exams, or an athlete who trains consistently performs better in competitions, those who invest their time wisely today will find themselves well-equipped for future challenges. This quote encourages a mindset of dedication, responsibility, and excellence. Instead of waiting for external circumstances to improve, It reminds us that the key to a better future lies in our own hands. By consistently striving for excellence today, we create opportunities and success for ourselves in the future. Ultimately, this quote serves as a reminder that the future is shaped by our actions in the present. If we want a better tomorrow, we must commit to giving our best effort today, whether in work, relationships, or self-improvement. Every small step we take today contributes to a stronger, more successful, and well-prepared future. As we wrap up our session, I encourage you to subscribe and hit the bell icon so you won't miss any of our upcoming chapters. It's your gateway to mastering transmission line supervision. That brings us to the end of today's Chapter 13 about construction activity topic survey. Next time, we'll dive into the fascinating topic of geographic coordinates. Until then, take care and thank you for watching.